Time to play the game!
Hello, in this video we'll talk about arrays. Actually, earlier on we've seen we could declare A and B on the stack, and that we could go from one to the other, because they're almost stored in the same place. Now, I'd like to have 10 integers rather than declare 10 variables, like A, B, C, D, E, F, G, etc., till I have 10. I'd like to declare a variable that possesses 10 integers within. That's called an array. Here's a piece of code used earlier. We could declare an integer by writing integer b. Now I'm going to call it tab, and you're going to discover a new syntax. When I write int tab square bracket 10, I'm saying that on the stack there will be 10 integers. And that tab will be some sort of implicit pointer. On the first of these integers, we're still using pointers. Now look, here is put address. I used to give it an address. Here I'm going to give it tab instead. And if I want to display one of tab's numbers, so far I haven't set any. We'll be able to access one of tab's elements by using square brackets. For example, the first element is tab square bracket 0. You'll understand why in a moment. First, let me show you that it works. Compiling and executing. We can see that the tab is an address, and that tab 0 has the value of 42. Now let me explain why the first element of tab is tab square bracket 0. Basically, tab square bracket something is like writing star normal bracket tab plus brackets content close bracket. When I write this, see these two lines, tab square bracket equals 42, or star normal bracket tab plus 0 equals 42, it's the exact same thing. Let me prove it to you. Recompiling, relaunching, I still have the value 42. I told you that tab was some sort of pointer that points towards the first element of an array of integers. When I do plus 0, it's the address of the first element. And when I do star bracket tab plus 0, I get an integer which is the first element of my array. So tab square bracket 0 and star tab plus 0 is the same. If I wanted to access the fourth element, well, I'll do tab plus 3. Tab plus 0 for the first, tab plus 1 for the second, tab plus 2 for the third. Remember, in a previous video, normally with plus 3, as we're using integers, by taking their real size into account, it's actually plus 12. Plus 3 times 4, because an integer equals 4 bytes. So I've used both, star tab brackets tab plus 3 and tab square bracket 3. And it works. So here I have a memory slot that's allocated 10 elements. If the first element is at plus 0, the last is at plus 9, and not at plus 10. Be careful. When you have an array of 10 elements, the last element is the array's length minus 1 to access it. Because in order to access the first element, we access it by 0. Now that we've seen this, I'm going to prove that it is indeed a pointer. So imagine, I'm going to use star ptr and do ptr equals tab. Tab being an address. I hope it compiles. It does, all good. So ptr has taken tab's value. Reminder, tab is an address, the address of the first element of the array I allocated. So if I do star open bracket ptr plus 3 close bracket, ptr plus 3 is an address. Star open bracket ptr plus 3, let's give it a value such as 867. And here I'll display tab square bracket 3. Will it work? $867. All good. See, arrays are just another way of writing pointers arithmetics more simply. And at the top it also allows us to declare more elements. Just to be thorough, let me show you something else. Let's make an array of integers and underneath I'm going to create an array containing 2 elements. Actually, let's add more things. This one I shall call tab PTR. It will contain 2 pointers to integer. It's an array of pointers to integer, and we could do this to infinity. Pointer to pointer to pointer. Let's imagine now I want to modify tab2 from tab PTR. Tab PTR square bracket 0 is a pointer to integer. So it'll take an integer's address. So let's give it tab's value. Tab PTR square bracket 1 is equal to tab 2. And now I want to modify tab 2 square bracket 3 through tab PTR. I've linked tab PTR square bracket 0 to check out tab 2 square bracket 3. It's easy. Tab PTR square bracket 1 represents tab 2, and now square bracket 3. If I set the value to 42, it should work. Let's remove what we don't need. Let's give it a shot. Sorry, this video is so long. The value of tab 2 square bracket 3 has been set to 42. You'll see that this is all very logical. How could I rewrite this with pointers? And this is the last thing we'll see in this video. So, how could I rewrite this with pointers? And I've said when you do something, square bracket something. It's the same thing as doing star what's on the left plus what's in the brackets, close brackets. So I'm going to transform tab PTR square bracket 1 square bracket 3 into something with asterisks. Let's start by moving the square bracket 3 and add an asterisk. What's on the left of square bracket 3? It's tab PTR square bracket 1. So plus 3. That is equal to 42. Normally those two lines do the same. Let's test this. Still displaying 42. Now let's do the same with square bracket 1. Recompiling, relaunching, still displaying 42. The point I wanted to make, the line below is equivalent to this. So, the point I wanted to make. We said that tab PTR was an array of pointers to integers, to int. As I said earlier, that tab was an array of ints. So tab is some sort of pointer to int. So tab PTR is some sort of pointer to int. And you can clearly see, because in order to access my int to set its value to 42, I had to use 2 asterisks. First time, I took the address contained in tab PTR and added 1. Talk about bytes. I checked what was at this address. At this address, we actually have tab 2. And then I added plus 3 to tab 2. And also checked what was at this address. So if I wrote tab 2 square bracket 3 and gave it the value of 42. Here you go, those were the basics of arrays. Beware. Sorry, I'm almost done. Tab is not a pointer to int. Be really careful with this. Basically, behind your array, there's a pointer to int. You can access it in the function using 2 square brackets. But as soon as you want to pass it another function, you'll have problems. You'll have to try things with arrays of arrays. But now that you've seen how to make array pointers, and simple arrays, arrays of integers, arrays of pointers, it's up to you to practice and test things. That's it.